The Earth's magnetic field is getting weaker. In the early 1800s, a guy named Gauss, G-A-U-S, I don't know how to spell his name, G-A-U-S-S-E or Gauss, I forget, just one S. Anyway, Gauss figured out a way to measure how strong is the Earth's magnetic field. There's many different ways to measure the strengths of magnets. For instance, if you took a magnet and see how many paper clips it'll hold up. You know, to make a string of paper clips. Eventually, it won't hold the string anymore. It's not strong enough. A stronger magnet will hold a longer string. You can get an electromagnet like at a junkyard. The guy flips a switch and electricity goes through this coil and becomes a real strong magnet and picks up a car. Shuts the switch off, electricity stops flowing, car falls. The electromagnet only works as long as the electricity is running through the magnet. You can do that, you have them on your car if you have an electric door lock. When you hit the switch, it is sending electricity around a coil of wire, creating a magnet just for a second that pulls a metal rod down. When I was in electricity class in high school, I made for a project a golf ball return. You hit the golf ball, it flows into the hole, and it hits a little switch in the hole, which triggers an electric circuit and makes a magnet. I just had a steel rod, would go, there's a coil of wire and a steel rod. As soon as electricity went through there, boink, it would come out and hit the golf ball and knock it back out to you. You don't have to go get it. What a waste of time. First place, knocking the ball in the hole is a waste of time. But, right? Okay. But the golf ball returns that way. Just a little magnet, you know, just becomes a magnet momentarily. You can actually shoot a steel rod that way. It's a very inefficient way to do it, but it can be done where you have a rod and a coil of wire, you energize it, shoots the thing through. The problem is, when it gets to the middle, as soon as it gets past the middle, it starts pulling it back. So the trick is, as it's coming in, shut your power off so that it'll keep going. Otherwise, it'll go and stop in the middle, which won't do any good. Okay. As far as shooting it, there's all sorts of other ways more inexpensive ways to propel objects through space. But the Earth's magnetic field, ever since it has been measured by this guy named Gauss, it has been losing strength. It has now lost 6% of its strength in the last 150 years.
Could the gravitational pull hold the atmosphere in?
Gravity holds the atmosphere in. It has nothing to do with the magnetic field.
Is gravity, okay.
I don't think gravity and magnetic field are related at all.
Is gravity declining at all?
No, gravity's all staying the same as far as we know. Gravity appears to be directly related to the mass of the planet. How many pounds of dirt are here? That doesn't change. It's maybe increasing a little as more cosmic dust and stuff falls in, but it's insignificant. So magnetic field and gravitational field are totally unrelated to each other. Some planets have a magnetic field, and some planets and some stars or some moons have a magnetic field, some don't. I don't remember if the Earth has, if the moon has a magnetic field or not. We could look it up. If it does, it's not much of one. Okay. One of the Jupiter's moon, Ganymede, they discovered as they sailed out there past Jupiter, one of its moons has a real strong magnetic field. Most of them don't. They would all have gravity that would be directly proportional to their size. A bigger planet would have, or denser planet, more massive planet is the proper word, would have more gravity, but that would be unrelated to the magnetic field. Okay, the Earth's magnetic field has been declining. As they've studied this data, they said, okay, that means it used to be stronger. Right? How strong can the magnetic field get before you start to create a problem? Thomas G. Barnes was a PhD in physics and taught physics at the University of Texas, El Paso. I've spoken there several times at the university and in El Paso at different churches. Thomas G. Barnes is, I think, probably like 82 years old now. He's pretty old. Brilliant man when it comes to the Earth's magnetic field. He was considered one of the world's experts on the Earth's magnetic field. He said, the magnetic field of the Earth is declining. Here's the data. He said, this shows it cannot be more than 25,000 years old. We'll get into more of that in a minute, but according to Thomas Barnes, the magnetic field of the Earth puts an age limit on the Earth of 25,000 years. Now, those who believe in evolution don't want any age limits. They certainly don't want less than 25,000 years, right? You got to have zillions of years to make your theory look good. I think it looks bad anyway, but even with zillions of years. But you certainly look really bad without zillions of years. So, factoid. The Earth's magnetic field is getting weaker. I've never had anybody argue with that one. Even the atheists will agree, yes, it's getting weaker. But, they say, that's only because it's getting ready to reverse again. What do you mean again? It never has reversed. So they teach the Earth's magnetic field is reversing because that's the only way they can get out of the problem. The fact is, it's declining. All we've ever measured is it's declining. Nobody's ever seen it reverse. We don't know how it could reverse. If you want to believe it did, that's fine, but that's not science.